Hello, my name is Dr. Faisal Safi. I'm teaching fundamentals of microelectronics as well as this lab, the microelectronics lab. So in this video, I'll show you how to measure the built-in voltage or the barrier voltage of a diode. Okay, so what you are going to see, what you are seeing with in there, so is a multimeter. Okay, I'll bring it closer for you. Okay, so this is just a simple multimeter. Okay. By Agilent, okay, and we are going to use that to measure the built-in voltage. But before that, I'll show you the wrong way, and then we'll do it the right way. Okay, so what's the wrong way? So can we really measure with a voltmeter the built-in voltage? Because that's how we measure the volts, is using voltmeter. So we'll do that, and then we'll do it the right way. Okay, cool. All right, so without further ado, this is the diode we are going to measure. We try to focus on it. It's a bit hard to focus, it's quite tiny. Okay, let's try that. Okay, let's try to focus. Oh yeah, it's very hard. Okay, cool. All right, let's see now. Okay, now we can see it better. Somehow. Let me try to change the direction here. It's very hard to see, I know. Let's see now. Okay, so this is the diode. You can see there is a strip on the right side. It's a black on the other side. So the diode is composed of two terminals, cathode and anode. So is that right ring the cathode or the anode? I'm talking to those who do not know, of course. For the experts, it's a piece of cake. All right, good. So we'll know that by the end of the talk, okay, or the presentation. So now, without further ado, let's zoom out a bit, okay, and let's use this multimeter, okay, across, first of all, to make sure that, you know, and this is basically the multimeter. As you can see, these are the cables. Let's see, they are intermingled, okay. So these are the wires here, as you can see. When you connect them together, we should not have any voltage. As you can see, it's very low, zero basically, okay, when they are open like that. All right, let's now put that across the diode, okay. So I will connect this on this side, and this on this wire on the other side, and let's measure. Didn't change much, as you can see, pretty much zero, and that's the delta V of any diode. If you measure the voltage across the diode, is zero. Oh, what is the built-in voltage? So this is the wrong way of measuring it. Okay, good. So now let's see the right way. The right way to do that is basically you use the same multimeter. As you notice in here, let me bring you a bit closer here. Okay, let's do that. Okay, you look here, you will find there's a port here with a diode. You see that diode? That's the diode port, and that will help us to measure the built-in voltage. Now, if you use the built-in voltage, the feature of measuring the built-in voltage, the barrier voltage of the diode, you have to choose this feature, the diode feature. To do that, you have to click, shift, and then diode. Very good, excellent. Now you can notice that there's a diode symbol there. Try to focus. Okay, you can see it there. And it says beside it, open. When the diode is open, when it is reverse biased, of course, before the breakdown. Okay, good. All right, good. Sounds good. So let's keep going. All right, let me do something here with the camera. Okay, good. So now what we are going to do, so what you can see, you see that the positive side is connected to this side of the diode. What's that side? Let me try to focus. To the ring side. So that means the positive side is connected to the negative. That's why it is open there, you see? Okay, good. Now the negative side is let's try to switch the connections. So I'll bring this connection to the other side and this one. So the negative side to the negative side and the positive side to the positive side. And voila, bingo. That's what you see in the multimeter is the built-in voltage, which is roughly around the value of our expected value, which is about 0.6, 0.7 volts. You can see there, it's really nice. And we know by now that this ring around the diode, this ring, is actually, that you see, is the cathode. And this is how we know the cathode of a diode, by seeing that little ring. It's like the ground of the diode. Okay, I hope you enjoyed it. Now the next question is the built-in voltage or the barrier voltage of a diode change with temperature? That's what we are going to see. This is again Dr. Faisal. I'm taking you now to this video. In this video we will show how the barrier voltage of a diode change with temperature. Okay, great. So what do we have here on the top right of this video is the barrier voltage we are measuring of the diode. Where is that diode? Is right down there. You can see. You can see that's the diode we are trying to measure its barrier voltage. And by the way, that diode is called has a name. And that's 1N4004. Okay, we are trying to measure its built-in voltage, and that built-in voltage or barrier voltage is about around 0.6 volt. Okay, so what we are going to do, we are bringing a thermometer, as you can see beside the diode. I will zoom again just to have a look at that. That's the thermometer, as you can see, and down there you can see it's a probe. Okay, the probe, which is this piece of metal that we are measuring, is called vernier temperature probe, which is connected to this thermometer beside it. Okay, great. And we are about 23 volt. The facility department here is doing excellent job by maintaining this temperature in the lab, which is the norm. Okay, so 23 degrees, good. So what we are going to do, we are going to blow with this heat blower the heated air on that diode. Okay, and see the temperature and the barrier voltage together, how they change. Okay, so let me start that. The temperature is on the rise. It's now 26, and the built-in voltage is now in the down. As you can see, it's going down again. You see, going down and down because the temperature has increased considerably. Now we are about, the temperature near the diode is about 80 degrees C, which is quite high, 90 now. And now, instead of 0.6, we are in about 0.3 volt for the barrier voltage. Okay, it's quite a huge difference, 50%. 50% with the temperature around what is around 150. That's starting to be scary. And now we are going back. Now I'm switching it off. Okay, the blower. Of course, the temperature will decrease. As you can see, this now is decreasing. As you can see, and look at the built-in voltage now. So as the diode is cooling down, the built-in voltage, the barrier voltage over there, you can see, is going up. Up, 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 up. You can see. Now this is a proof, experimental proof, that the barrier voltage does increase with decreasing temperature. In fact, if we have a blower but with cold air, we will see the opposite side, that the barrier voltage will do increase, in fact, according to a certain limit. And when the temperature increases, the barrier voltage, in fact, as you just saw, will decrease. I think this is a nice demonstration of what we studied theoretically, now in the lab. Hope you enjoyed it and have fun. Bye now.